So, hi everyone. Uh, Thanks for the introduction. So, a little bit about myself. Basically, I'm from Uppsala University, working as a researcher there, and together with my academic activities, I'm also involved in the SNIC cloud project from this project, and I'm basically the cloud architect for that. So today what I was thinking to do is to give you a brief overview about our activities and what we would like to do and where we are heading and how basically OpenStack is helping us to achieve the goals. So since it's SNIC in the beginning and even in the logo, so I think it's better to get started with a little bit about what is SNIC. So SNIC is Swedish National Infrastructure for Computing. And it's a meta organization that is partially funded by the Research Council together with the partner universities. And as you may know that there are with different universities within Sweden, they have their own local data centers as well. So here are the 6 HPC centers. And the highlighted ones are basically the ones that are participating in our cloud initiative. So SNIC is basically predominantly providing resources for compute and HPC kind of computational facility and the storage one. And cloud is something that recently has been started within the SNIC umbrella. So what actually the SNIC cloud is basically it is infrastructure as a service and powered by OpenStack. We have it's basically a platform that provides a facility for the end user, specifically towards this academia, to see and find out the things that what are the benefits about the cloud resources that are available. It is basically based on our current architecture is based on mostly on the legacy hardware, like old hardware that was previously used by the HPC kind of environment. And the aim is for this project is to see if we would like to have a national scale cloud infrastructure, how it should look like specifically for the academic purposes. And together with that, how the current workflows that are in the academia, how basically we can make it in a way that we can provide a scalable, agile, and vendor agnostic kind of behavior from those kind of applications. And also, there are some high-level services that are also available through the OpenStack platform, like Sahara, Heat, or Trove. Can we really use that on a national scale or not? And together with that, overall, a platform where users from the academic community having a specific requirement with predominantly with the HPC kind of workflows, how much they can leverage from this cloud kind of infrastructure. So basically, to use what it is basically to use the virtual environment for the system. So that is basically the aim of this project that was started a couple of years ago, and we are trying to address things along these lines. So in a big picture, how it looks like, as I said, that there are 6 HPC centers within SNIC, and out of these 6 centers, 3 are participating with this activity, and it's basically one in Umeå, north of Sweden, Uppmax from Uppsala, where I belong, and C3SC in Gothenburg. So these are the 3 centers that are participating in it. So our big picture of the cloud looks like we have region-based deployment. And why it is like that? It is the whole idea was that when this project was started, there was 3 organization or independent bodies that would like to contribute in this project. But in the end of the day, if it is independent organization, they have the resources within their premises, and they would like to contribute as well, but it is not like one data center, and it is not like clear from the very beginning how to handle all the resources in a one umbrella kind of operation. So yes, we had organizations that would like to contribute, but we need to come up with a strategy where how these three different organizations can work very well. I think if you remember from the CERN talk, they have cell-based deployment of the OpenStack, and that is quite possible when you have very dedicated connectivity between the resources. But here, it's a pilot project, and we would like to come up with a strategy that is useful and practically doable within the amount of resources that we have. So we come up with this idea of enabling things as enabling each site as a region. Region means they are autonomous. They can provide services independent to other regions. For example, in our cloud setting, how it is basically Uppsala. In Uppsala, we have a big community from bioinformatics and systems biology, and there we have more requirement to provide analysis tools. Whereas in HPC2, there are more new hardware that is available. So HPC kind of workloads can be very useful for to use those kind of resources. And there are some other special needs from the C3SC. So we thought that this approach is even better for us to design a system where each center have its own autonomous power on the cloud, but still they can have we can have a one window operation on a national scale. So what we did is that we have 3 data centers. We have one dashboard, and the keystone is shared. So basically what we are doing is that we have one place where all the endpoints are sitting together with the dashboard, and then whenever users switch from one region to another, it just completely ends up in a specific region and started to do their things. But with this approach, the one drawback that one can see is that if I would like to have live migration between regions, that is not possible. But at the same time, if somebody would like to have active mode applications where different regions provide the same kind of application, what if region goes down and the other take over? So these kind of things are still possible with this kind of architecture. So that was the initial concept. We have started with that, and I can say successfully achieved that. So current status of our project. So it was started in February, almost like it becomes operational in February 2015, and then we are providing the services. There are courses that we are offering. There are a number of projects that are using our resources, but still we cannot call it a production grade system yet. And there are a lot of reasons behind that. First of all, the system is based on legacy hardware. Second is that we are lacking the manpower that ensures that it's a production quality system. But still, it is very interesting to see that from March 2015 till July this year, we have almost, currently, even if I include the ones that we have added after that, we have more than 65 projects in the system, and the size of each project varies. So project means that one research group would like to get some resources, and then all the users that would like to use the resources are within that. So if I count that correctly, it is more than 250 users that we have in the cloud. Still no production quality system, but we managed to provide facility and a facility for the Swedish academia, where we have 60 projects running in the system. That was very interesting. So initially the things was started with 100 physical cores, and now we are heading towards 4,000 cores by the end of this year. And these are basically the ones that are distributed on different centers. Yeah. So what we have achieved so far when we have started till now is that the first deployment that we had in 2015 was based on Kilo, and there were only some basic services that are available: Nova, Cinder, Object Store, and Neutron. And all the installation was manual. It was a very tedious job to maintain that kind of system when you don't have like a proper system that can monitor the things, or if there is no high availability kind of thing. So but we have managed to survive during that time. And in 2016, we have switched to the Liberty release, and there we have for this release we have used OpenStack Ansible based container deployment, where we have LXC containers are basically the ones that are providing different services, and then we have this HA proxy and keep alive kind of components that provide us a highly available system. So together with this kind of deployment, we have also managed to achieve this orchestration component of OpenStack Heat service, and then data processing with Sahara. So all these things are currently available. We have a, like you can say, highly available system, but still there are more things to do to make it more like a stable and production quality system. And for our deployment, we have mostly used Ceph and Ubuntu systems. So here is something about how the resources currently look like. Yeah.
Why did you switch from CentOS to Ubuntu?
Yeah, because there is more support available. If you started to search for something, and there are more what we have experienced is that if you started to ask or discuss something around some specific problem, if you have Ubuntu, there are more people who are contributing in the system, and they can respond accordingly. So we thought that it's better. And also, for this OpenStack Ansible, they are predominantly working with the Ubuntu release. They said that they're gonna release CentOS version as well, but currently they are more focusing on the Ubuntu one. So here is something about the resources that we have. Uppsala, our default region, OpMax. Here we have old like decommissioned HPC hardware, and we got that. We deployed OpenStack here with Ceph and Ubuntu-based system. We have HPC2N. It's rather a small setup, but all the hardware is quite new. And then we have C3SC, another region that is mostly based on, again, decommissioned HPC resources to provide the services for that. And the regions are there, they are operational, but still there is a little bit more work to do when it comes to switching between different regions with the users' requirement and everything. That's why we are heavily relying on the one that is in OpMax, and here we just switch whenever there is a need to provide things. Yeah. And by the way, we have our cloud basically cloud system expert here, Andreas Wallin. If you have more questions about like how the system is actually deployed with the OpenStack Ansible containers and stuff like that, there are more informations available with him. And then what we have achieved so far is basically, together with providing infrastructure as a service, we quickly started to get requests from the user that, okay, can we have, for example, service X or software X enabled in the system, and that is basically some kind of scientific software that they would like to use for their research. So we started to think that, okay, the one that are already enabled in a cloudified fashion, maybe it is easy to provide that as a service. So first thing that we have tried was Chipster as a service. It's more like a, you can say, a visualization software that provides analysis facility for the bioinformatics. And then together with providing Chipster as a service, there are some more tools that we have enabled. For example, Galaxy. And those are available, but we have also found that there are some softwares that were previously only using HPC resources, and they started to use our systems pretty nicely. And some of the stories are basically from proteomics. We have seen a use case where they are using cloud resources very efficiently. Estimating failure probability, another application that is using our cloud resources, and they are quite happy after moving to the system. And then this research environment for clinical metabolomics. So with all these things, we started to get this response that, okay, this is something that is interesting, and people would like to use these kind of resources, though they are a bit skeptical about how actually things are happening. But what you can see here, it's mostly the scientific workflows that are working. But there is another very big area that we are still struggling with, is when it comes to performance and reporting the usage of the resources. For example, I have one cloud infrastructure that is based on a certain number of hardware specs, and then all of a sudden, if they run and if there is an overcommit allowed on the resources, then the numbers that you can get from running a specific application can be very different when it goes to a different cloud. So how one can really use HPC kind of workflows and make them reproducible, the numbers that they are using for the other environment. Because if it's about research, they would like to present their results, and results should be reproducible. So these are the ones that are more towards like how the workflow or the chain goes. But there are more use cases that we are still looking at, like how to report the results in a more credible way when it comes to HPC world. But I think if we see these success stories, I think it will be honest to say that it's not like the success story of the project, and it's not only the success story of the SNIC cloud, but it is also the success story of the OpenStack community as well. Because without providing the kind of software stack that people are working on it, these kind of things are very difficult to manage. So yeah. So another aspect that we have realized while working on the SNIC cloud project is that we have heard lot about like when researchers and people from our community, they started to use the cloud resources, the immediate response that we get is that clouds are not cheap. I have moved my workflow from my data center to cloud, and they are quite expensive. Yes, if you started to use your cloud resources in a same way as you are using your dedicated resources, then you will not gonna get the benefit that cloud can promise. So then we started to think that it is also good to somehow provide the workshops and training for our user to show them that what are the possibilities that they can use, and when there is a chance to modify the application, what are the areas that they should focus on. And we have started our workshop series addressing the issues of very basic usage of cloud towards contextualization, orchestration, and what it means when it comes to the virtualization, how the application should look like, what is basically elasticity in terms of cloud environment. So all these things we thought that it is together with providing an infrastructure, it is also good to educate about these kind of things. So within this scope of workshops and tutorial, we have organized so far 4 workshops, one in Uppsala, second was more like for the bioinformatics community that is currently predominant in our cloud environment. SciLife Lab Uppsala, then SciLife Lab in Stockholm, KTH Stockholm, and the next will be hopefully in Chalmers. So with this, what we would like to do is basically to educate them in a way that they know how to deal with the cloud kind of resources. Yep.
Quick question. So, what are the mistakes? Oh, sorry. So, what are the mistakes that you noticed? You said that they are using it in an old way and not in a new way. Is it teaching them how to spin up when needed and tear down when not needed instead of running it 24/7, or what is it?
Yeah, it's basically the same. So how a classical batch-oriented fashion of running an application is that you have a head node and then there is a workers. And if there is no auto-scaling in the system, then it means that the number of workers that you want to have for running an application, they are all have to be up and running, no matter what there is a load coming on the system or not. So that is the kind of thing that is a bit different with the cloud kind of resources, because you can spin up VMs very quickly, and even if you want to spin up more resources in a less time, then containers are there. But there should be some kind of mechanism that tells the system that, okay, there is a workload, then switch to that many of resources or stuff like that. Or the kind of thing that I have explained about the active mode of the application, rather than running everything in one region, deploy it in a way that there are two copies of it. So if one goes down, there should be something that can catch up. These kind of things. And together with that, it is. I think it's also interesting to mention that we have seen a quite hype around containers. But when it comes to the user and the usage of the containers, people have no idea what it actually means. Is it only the containerization of the application, or there is other benefits as well? So, and what is basically OS level virtualization and stuff like that? So these are the kind of things that we thought that it will be interesting to explain and give something around these basic concepts. So we started to work on the workshops, and most of the material that we have produced is available via GitHub. If you want to try, the material is available. You can give a try to that. And that basically contains the heat-based orchestration and how basically contextualization works in terms of a single machine towards cluster-based contextualization kind of stuff. So these kind of material is already available. And also we have a nice basic guide where you can attach a volume, create a VM, and then try to see how much performance you can get compared to if you have a object store kind of thing. So these kind of tutorials are already available. So that was about the workshop. Here is our team that are working on this project. So Andreas Helander is the project leader from Uppsala, and then we have at least 2 to 3 personnel in each center. Andreas, me, and Andreas Wallin, we are working from Uppsala. Then we have Ingerman and Lars from Umeå, and Matthias and Daniel from C3SC site. And together with all the activities that we are participating in within this SNIC Cloud initiative, we are also actively participating in this Galena Cloud initiative that is basically initiated by the NIC, the Nordic E-Infrastructure Collaboration. So with Galena project, what they would like to see is to create or find out the ways how a Nordic level cloud-based community can be developed, and what it means to develop a community that is geographically distributed, not only just by the regions, but with the different countries, or based on different countries. So that is basically the idea. We are also participating in that, and try to see how different user community can get used to the kind of resources that we are thinking that OpenStack can help us. So we are also working on that project together with our own things. And I think another thing that I can mention is that none of us is working full-time on this project. So mostly 40% of our time that we are spending on this. But thanks to, again, OpenStack community, that we managed to provide that kind of facility to run different kind of services. And another thing is that we are also running PhD level and master level courses using this platform. And there, the idea is that we don't want to give only the theoretical knowledge to our student. We would like to give theoretical concept in the lecture, but all the labs and everything is basically designed on the real cloud infrastructure. And what we would like to give them is to feel the difference when it comes to how you design an application compared to how you design an application for the cloud infrastructure, because previously it's only the software layer that you can modify or work on. But here you can design your virtual infrastructure according to your application's need. And then you can do more fancy things on that. For example, if one person would like to have a Hadoop setting, and HDFS should be designed in a way that is more geared up to handle small jobs, and one is to geared up with the big workloads. So there is a possibility to do that, but only when there is a possibility to work at the infrastructure level as well. So these are the kind of things that we would like to demonstrate and give training to our students. So yeah, that's what we are. And what we are thinking to do in future is basically we would like to provide more services in a way that users will not end up playing with the plain bare metal virtual machines if they are not comfortable to do that. I mean, in the end of the day, researchers would like to get started with their work as soon as possible. So, for example, these Jupyter notebook kind of stuff give them the feeling that it's not a batch queuing system, because sometimes we also get this response that, okay, you have a cloud, very nice, where I can submit my job. Well, it's cloud, you have your resources, you can use it whenever you want, and it's dedicated. You can click and start your settings right away. But if still there is a possibility and there is a need that more high-level services should be available, there are possibilities to enable these, and we would like to give a try to these kind of services. Together with that, another thing that we have realized over the time is that there are some very interesting open source data sets, scientific data sets that are available. For example, this 10,000 genome, that very many groups working on these kind of data sets. It will be very interesting to have those available through our infrastructure, so that the collaborators can design an application where half of the workflow runs on their cloud, half comes to our cloud, use the same data set here, use the same data set there, and get the results way quicker than just working on one site. And same for our users as well. They can use data sets that are locally available, and they have the services or the code that they are developing should be in a way that it can fly over to another cloud and started to use these ones. So we are also thinking to provide these kind of open source scientific data sets. Another thing that is very important when it comes to providing a national scale infrastructure is to allow very many users from the community to use the infrastructure. One way is to ask them to create new logins and do all the things, but there is a very nice federated identity kind of things that are already available. So we are thinking to work on, actually we have already started to work towards this SAML and Kalman 2 login capabilities. So we are working on that, and we would like to enable our Keystone using these. So whenever a user got a username and password or some kind of credentials from a university, they can use the same credentials to log into our system rather than maintaining each island separately. And another thing that is very interesting that we have figured it out over the time is that when it comes to the HPC kind of environment, there are certain kind of requirement when you ask for the resources. For example, CPU per hour. But if the same kind of request comes to me as a cloud architect to approve a project, what it means to me. And if even on my side, I started to convert all these numbers to a number of virtual machines and quotas and everything, what's gonna happen if my user tomorrow would like to use the Amazon resources or these Google Cloud resources? How he will convert by himself all these things? So we started to think that it will be much better to have a virtual economy model for our users, so that whenever they come, they will get some virtual money. They started to use in our infrastructure the resources by using that virtual money. And then when they move to the public cloud infrastructures, because we don't want to our user to just lock on our infrastructure. Whenever they go to the public providers, it's just the virtual that translates to the real, and that's it. So that is another initiative that we would like to take. But there is another interesting aspect of this virtual money is, like, most of the time users start their resources and they forget to turn it off. So we would like to have a mechanism where we can show them after some time that, okay, if you started a bunch of virtual machines, yes, you can start, they can run, you can have them as long as you want, but then your money will be used. So try to keep up with the solution or architecture in a way that you can really utilize your resources best. And if there is something left in the end of the project, then you can get that as an additional in the next phase of the project. So these kind of things that we would like to educate from this idea. And also we got very positive response from the Galena and the Nordic collaborators as well, that this could be an interesting thing to see, and especially when it comes to open source, when it comes to the organizations like research community and universities, it's difficult to always go for the real money and all the time using credit cards and things. It's better to have something like that. And the last point is, yes, we are doing our doing our best to provide this kind of infrastructure for the academia, but at the same time we would like to have more collaboration so we can share our experience with others and get some knowledge from the other service providers to see how we can build things in a more better environment. And with this, I would like to add another thing is that the main idea of the SNIC Science Cloud is not to compete against public cloud providers. We are not the one that can handle these kind of heavy requirements from the SLAs and stuff. But what we would like to do is to provide a platform where our user get familiar with the environment, learn how to utilize the resources, and get the maximum benefit when they move to the real environments. So these are the kind of things that we really would like to push on. So with that, I think I have covered most of the things that I would like to say. So if you have any questions or, yep.
Sorry, I missed the first part of the presentation. I have one question. Is this project widely used by the universities or is well known by them?
Yes, it's basically open for all the Swedish universities. So if a student or a researcher is working in a Swedish institution, they can ask for the resources.
Okay. So it's usually used by computer science team or all kinds of team, because for some team they might have no much idea about those cloud OpenStack stuff.
Yes and no, but what you can see from here is proteomics analysis, and these are all the kind of areas where bioinformaticians are working on, and we have some applications from aerodynamics. People are doing their research and doing their analysis. Yes, we have applications that are working more towards machine learning and stuff like that. So I cannot say that it's mostly from the IT department, but yes, I think we have a pretty widely spread community. But it seems like if I remember correctly my numbers, then that bioinformatics or systems biology people are quite active in terms of using these kind of resources.
Thank you, Matt.
Yeah.
You said at the beginning you do not have live migration. Was that a choice by you, or was it more like we don't have the possibility?
Well, live migration is possible within the region. And outside the regions, communicating when it comes to the two different regions, there are different solutions within Neutron that can enable these kind of functionality. But here, our understanding from the very beginning was to provide a solution that can demonstrate that we can provide multi-region kind of functionality where the regions are more autonomous. We don't want to push certain kind of network settings on each region. For example, if I would like to have these kind of live migrations and all these kind of fancy things between regions, then there are more constraints that need to be handled on the region side. What we would like to do is to, for example, in the early in the first release, HPC2N region was running Nova network. We were running in OpenMax GRE tunnels with Neutron, and the one that was in C3SC, they are running Linux Bridge. So we all have different kind of settings, and it is basically how much resources we have, how much expertise we have in the local data center, but still we would like to have a platform that can provide the services from different centers. So we would like to reduce the workload, but still want to provide the maximum possible options that we have. So that's the basic idea.
Okay, thank you. Another question. Research data could be sensitive in some ways, I think. Have you considered it when you're the national, international kind, as a Nordic collaboration?
So there are a couple of initiatives that those are parallel to SNIC Science Cloud, where they are working on the very specific sensitive data kind of initiative. For example, there is a SNIC Sense project that are working very closely towards how to provide a facility where you can have your sensitive data. So that is not in our mandate right now to provide this sensitive data, but we are more towards providing a platform where user can make the maximum benefit of the resources. So sensitive data is something that we are not actually handling in our resources. And again, it's not a production grade system, so there is no way we can offer these kind of services. But yes, at Swedish National Infrastructure of computing level, there are separate initiatives that are dealing with these kind of things.
Okay, thank you.
Yeah. So,
any more question? Or
if not, I have one thing to mention about, like, these are the success stories. how about the failures? And how many times? So I thought maybe one example that can be very interesting to show you, or like what happened. So a year ago, what happened was that we had designed a student lab. There was 50 students sitting, and the same bright idea of giving them this power of to show them that, okay, how flexible the cloud is and how good things are. We said that, okay, each can start their own Spark cluster and can do some data analysis, and we have written a very nice, interesting number crunching job, and we thought that, okay, yes, students will like it. They can somehow play with the infrastructure in terms of like how to set the Hadoop and stuff like that, and do all the fancy things. So it turns out it turns out to a disaster, because when everybody started their this Hadoop kind of setup together with Spark, the compute node have like kernel panic, blah blah blah, boom. So the system goes off, and that is because that was the time when we first time realized, like, okay, there are options available in the infrastructure side that one can use for certain kind of workloads. For example, if there is a web server that is running and there is a load that comes off and on and off, then you may have this kind of overcommit options that one can go for. But scientific workflows are not something that you can really handle with these kind of settings. So these are those were some of the things that we have learned over the time, and it was a bit embarrassing in the lab that when I was lecturing like 40 minutes, how cool it is, everything works fine, and then all of a sudden it died. But yes, things happen, and we are still learning. We are trying our best to support that. And by the way, how we are currently handling all this is basically we have now dedicated one center, or one, you can say, the zone within one region that is dedicated for providing these kind of services. But still, there are other options when people just would like to develop an application or test their application. They can use the shared resources. That's not a problem. So we are trying to make a balance and try to see what kind of workloads are there, what their requirements are, and where we should recommend them to run their infrastructure. Yeah, so thank you.